Hi, this is Tony Zhang, researcher at Fortis, and you're listening to Experiencing Data with Brian T. O'Neill.
You're now experiencing data with Brian O'Neill. Experiencing Data explores how product managers, analytics leaders, data scientists, and executives are looking at design and user experience as a way to make their custom enterprise data products and analytics applications more useful, usable, and valuable. And now, here's your host, the founder and principal of Designing for Analytics, Brian O'Neill.
Welcome back to Experiencing Data. This is Brian T. O'Neill, and today I have Tony Zhang on the line from Fortis in Munich, right?
Yes, exactly.
Excellent. And you are a researcher. I don't know, do you consider yourself an AI researcher? Or maybe you could tell us a little bit like your background. Is it computer science or design?
Yeah, I'm a researcher in human-computer interaction, so computer science, but at the intersection with design and psychology maybe, and more specifically human-AI interaction. So how can we make AI systems, or how can we design them in a way that people can actually work with them?
Excellent. Yeah, and I first heard about your this paper. So we're going to be talking about some findings from a study that you ran recently. And I originally heard about you through Ben Schneiderman's HCAI mailing list that he puts out. And he does a great job of kind of summarizing research in the field. So if you are a listener who's curious about the human factor side of artificial intelligence, how we're designing, how to think about the design of these systems and less on the technical build side, I definitely recommend his Google group. If you just Google HCAI, Ben Schneiderman, I'm sure you'll find a way to subscribe there. So just to kind of jump in though, Tony, to your work here. So I'm going to summarize this. You're going to please correct me if I get this wrong. And so in my words, what I took out of your findings here is that you ran a study with end users that were consuming recommendations or predictions from AI-based systems. There were two different applications basically that were provided to the users, and you wanted to see if the designs of these had any impact on the outcomes that the users had. And so I think both of them leveraged large language model capabilities here. So when we say AI, we're primarily talking about that. Is that correct?
One of the applications, yes. The other was not. Yeah.
Oh, is it like traditional machine, like just machine learning, forecasting, like?
Yeah, in the back end, it was actually not even machine learning. It was more or less faked, but
okay.
It was just using some sort of cost functions to rank some. You didn't introduce the application yet, but airports to rank them.
Right. So yeah, and there was an airport we're going to talk about. There was a pilot use case or scenario, and then there was one in the trading space around ETFs or exchange traded funds here. But the short answer is the findings here that you guys found. The findings that you found. Wow, that was terrible. But people understood what I meant. The core finding here was that you found that there were better outcomes for users when there was forward reasoning used here. So in short, what this means is when we rapidly provide the answer immediately or a recommendation here, there is a cognitive cost to having to reverse engineer how did you arrive at this information and is this the right choice for me or not, versus a second application where it sounds like the application was prompting users along the way. So they're moving forward through the thinking process instead of reverse engineering the answer. And then you looked at what the outcomes on the tasks were. And this had to do with a study of pilots having to find an alternative airport was one of them. And I guess the other one was figuring out whether or not is this portfolio of exchange traded funds right for me or not? And I want to ask you about like, how did you determine the success criteria later? But did I get all that right just as kind of a high level summary, or do you want to like correct any of that?
No, that was a pretty good summary, I would say. So yeah, just maybe to add a little bit of context is the motivation for the research was that in the overall space of human AI interaction, people usually find that it's somehow hard for people to work with AI, for instance, because they tend to over-rely on wrong AI suggestions. So even if the AI is wrong, you might not notice it, and then you just go with it. And then researchers try to fix this issue, but usually they stay in this idea that AI should just give you a recommendation, just solve the task for you, and then you as the user, you decide what to do with it. And I just thought, why do we need to keep within that model, and can't we think about a different way to use AI? And that was the whole motivation, the forward reasoning, as you said. that was the main goal, to help people go forward throughout the decision-making process.
Got it. Can you talk to me about, I don't know if unhealthy reliance is the right way to frame this, but if we use that language to talk about what's wrong with give them the answer immediately, quickly, what were your metrics that you used to say over time or during this study, there was a signal here of over or unhealthy reliance there? Like, how did you measure negative reliance?
Well, for the first application or the first study with the pilots, the way that I did it was, so in general, there were 3 scenarios that the pilots had to do. In one of the scenarios, I would construct it in a way that there would be one choice that seems pretty obvious at the first glance, and that's also what the AI would be hinting towards or suggesting. But if you think about it more thoroughly, you would notice that actually this is not that good of an option, and you should choose a different airport. And then I just looked into, given different types of the AI support that the pilots had to use, how often they would fall into the trap, so to say, to choose the AI suggested seemingly obvious answer. And what I found there was that with this recommendation-centric version, where the AI is just telling you fly to this airport, people tended to, or the pilots, the majority of the pilots actually chose this airport, which was not the best choice. And then with the forward reasoning versions, so I had 2 of those, but with both of them, I could reduce the amount of overline, so to say. So less pilots or few pilots chose this unfavorable option.
So there was an objectively best choice for the airport that was kind of obvious, or you all had a way to say this clearly should have been the choice. You could tell that up front.
It was not 100% objective. I mean, in general, that's also what's great about this application. It's not like a factual choice where you can clearly say this is right or wrong, but you could say this was not the best choice in this situation. So it would be, to make it maybe more concrete, it would be a situation where the actual destination airport where you wanted to fly to suddenly has a power outage. So the airport was closed, and then you had to, or the obvious choice was then to fly to an airport that was close to that one. It is also the standard airport that you would usually choose to fly to. So that was why it was seemingly the best choice. But in this case, because the entire airport was closed, it was not some or not some emergency that you as a single plane had on your on board. It was not an individual issue. It was an issue that is affecting the entire traffic coming to the airport. You need to consider that all the traffic going to the original airport would also want to divert to that airport, and then you would have a traffic congestion.
Right.
And I mean, if you have a very urgent situation, you can still get an emergency priority to land there, but it would just disrupt the entire system quite heavily. So usually you would try to avoid that.
Mm-hmm.
And I designed the AI system in my study in a way that or intentionally designed it in a way that it didn't factor in this traffic factor. And what I noticed was with the recommendation-centric version, it just said, yeah, fly to this airport, the close one. The pilots didn't think about it. While if the AI would not directly tell you, pilots would slow down maybe and think about all the factors that they would usually think about, and then come up with, oh, maybe I shouldn't go there because the traffic would be too heavy.
Got it. Can you help visually explain what these interfaces looked like? Like I'm picturing for the fully automated version, like, and I think you even mentioned there's a table, probably airport code, airport name, maybe one piece of evidence about why the system recommended it, and something quite basic like that. If that's correct, then what does the forward reasoning version of this look like? Because I know pilots are multitasking and like they can't spend too much time on any one thing, especially like a software interface. So what did that look like?
So I tried to keep the difference between those versions as minimal as possible.
Uh-huh.
So all of those were based on a table, actually, where you could see all the airports in your vicinity, and then also some data like the weather at the airport or
right.
the facilities at the airport and so on. And then in the recommendation version, the airport would or the table would just be ranked according to the recommendation by the AI. So the first 3 lines of the table would be the first 3 recommendations from the AI, and then in the table you would also color highlight the factors that would speak against each airport. So ideally, the top recommendation would not have any red or yellow highlights, which would show that the airport is all clear to go to, so to say.
Oh, okay.
And the further down you go into the table, you would see more and more red and yellow highlights.
So the columns like were attributes, those could be scored on like green, yellow, red or something like that, or yellow and red if it's negative.
Exactly.
Okay, got it.
So because pilots like to think in terms of risks about a certain option that they might have, and I wanted to just highlight the risks as an explanation, so to say, for the recommendation.
Got it.
Then I had a second version, which was following this forward reasoning idea. And there I just mostly stripped away the recommendation. So instead of letting the AI sort the table, I just relied on those color highlights as local hints, so to say. So instead of globally suggesting you this is the airport to go to, I would just locally hint at, hey, maybe look at this. At this airport, you might have adverse weather conditions, or at this airport, you might have a very short runway or whatever, and let the pilot then piece together for themselves whether that's a good option or not. So this was one difference. The second difference was the recommendation version. It would just pop up, so to say, or the pilot would just call it up once they want to do this diversion. So you have this emergency, and then you just call up the AI and say, hey, tell me, what should I do now? That's the idea, the interaction model, so to say. While for the forward reasoning version, the system would run throughout the entire flight. So even during normal flight, when you don't have any emergency coming up, because in prior interview studies before that, I found that pilots tend to work this way anyway. So usually when they fly, nothing's happening, but they try to get a good overview around about their surroundings at all times so that they are prepared if anything happens. And this was meant to support them. So just continuously showing them the table and always live updating the hints and the airports in the vicinity so that they would always have a good idea about where they are. And then in case of an emergency, the hints would then be more tailored toward the situation. This would be the change that the AI would do to react to the situation. So in normal flight, you would just see things that would be always of interest, like weather, while when you get a specific situation, let's say you have a passenger emergency, so a passenger on board has a medical emergency, then you would also see highlights for maybe medical facilities in the vicinity. It would just adjust the hints to your situation. And this would allow the pilots to always be in the situation and reason forward through their decision, because in the recommendation version, you can imagine you entered your emergency situation and then the AI tells you, do this for me, or you fly to this airport, and then you need to reconstruct. Does this suggestion make sense or not?
Got it. So in the recommendation version, there is a fixed set of column headers like weather, I don't know, busyness, some other attribute, each of which can be scored red, yellow, or neutral, meaning satisfactory or something like that. Is that correct? So that the columns never change. It's the same attributes all the time. The rows might change based on the AI, but am I getting that correct?
Actually, in the recommendation version, the columns would change based on the situation. So if you would have, for instance, a medical emergency, then the columns that show up in the table are just relevant for the medical emergency. So anything that's not relevant to your current emergency wouldn't show up. That's hidden from you. You can add them back in if you think the situation is more complex than what the AI is currently considering. Then you can say, okay, I still want to have the column about the runways or something like this. While in the forward reasoning version, the AI is, so to say, less opinionated. It would always just show all columns that are available to the system. So you, at all times, you just look at all the data that is available in the table. And the AI is just changing what it is highlighting, but it is not actively hiding some columns from you.
I see. So it's funny. This makes me want to tangent because I want to understand the design choices and how they relate to the prediction. So my first question is, how does the plane's computer, I should say, the software, know what the context for the emergency landing is? Like medical, weather, I don't know, ATC or air traffic control command, whatever it may be. How does it know? How does that inputted?
yeah, that's what the pilot is just inputting at the beginning. So in a recommendation version, you would just say, I have a technical emergency or a medical emergency, and then you can specify it further if you have the time or if you want to. If not, you just skip ahead, like generic medical or generic technical emergency or something like this.
Okay.
And then the system would just have presets, so to say, for your choice. And in the forward reasoning version, it works pretty similar. So the table is showing continuously even a normal flight. And then when you have an emergency, you get this menu where you say, I have a medical emergency now. And then the hints that the AI is showing would adjust based on your choice.
I guess I'm wondering, where's the reasoning part? Because to me, it sounds like the recommendation is initiated by a prompt from the user. The user has to input a cause. Why do you need to land somewhere else? Medical, technical failure, whatever it may be, and then the system responds. So it sounds like in the first recommendations version, you will get a list of recommendations. Like you do medical, it's going to recommend 3 airports or 5 airports or whatever. The columns might change to like number of beds available at hospital or whatever it may be, and then red, yellow coloring based if it's like number of beds 1. It's like, okay, maybe I'll go somewhere with a higher one.
Mm-hmm.
The other version, the forward reasoning one, tell me about what I would see that would be different there. You're saying the columns would not be dynamically adjusting, because I'm guessing they can't read a lot of prose. I mean, I don't know how verbose the assistance is from the AI here, but maybe I'm not quite following how they're different. So talk about the forward reasoning one. I type in medical.
Mm-hmm.
I'm still going to get a list of airport recommendations, but can you fill that in?
So still you see all the airports in your vicinity, but they are not sorted in any way. They are just sorted by, so the default would be by distance, and you can choose as a pilot what you want to sort by. But it's never sorted by the AI. Instead, the hinting is just changing. For instance, during normal flight, it doesn't interest you whether there would be a hospital close to the airport or not. So this would be something that is just not highlighted at all. While when you now choose, I have a medical emergency, it would just recognize, okay, I need to maybe hint you about this airport, that the next or the closest hospital to this airport is very far away. So even though it might have good weather conditions or whatever, I need to highlight to you that the hospital is pretty far away. And this is something that it didn't do in normal flight because it's just not relevant to the general flight situation, so to say.
So when you said hint, how did the hint appear? What was the design means of showing a hint?
Just the color highlights that are also present in the recommendation. So in the recommendation, basically the color highlights served as an explanation for the recommendation, while in the forward reasoning version, you only have these color highlights, and then they are basically just serving as warnings about each airport, what you might consider about each airport.
Okay, so if I'm picturing this in my head, then in the forward reasoning version, this table of airports is still probably sorted by distance, but the cells, like let's say number of beds, if that was a column, that might have a bunch of color highlighting in it. That would not change the sort.
Exactly.
They still have to make a choice about which one is right, but they have some heat map or they have some kind of visual information now about medical considerations. Is that correct?
Yeah, exactly. As I said before, I wanted to keep the difference between those two interfaces very minimal to just isolate the effect of the recommendation coming in. So if I showed you screenshots of those two versions, they would look very, very similar. The only difference that you would immediately see is that the recommendation version is showing like numbers 1, 2, 3 for the recommended airports, while they are not present in the forward reasoning one. But this actually is a pretty profound difference in terms of the interaction or the decision-making impact that the AI has. And also, as I said, there's this normal flight mode in forward reasoning, so that pilots are already immersed in the system and thinking with the system during normal flight. So it changes the process that they are going through while they are working with the AI.
I mean, it's an interesting thing because I would think that for a pilot that you're in, like, so the outcome might be you chose the right airport, but cognitive load on a pilot to go row by row and like look at all the column attributes. It's like, okay, first airport, closest airport is always at the top. Is it right? Yes, no. Go to the next one. Okay, second airport. That one's okay. Third airport. Like your eyes are like off the window. You're not looking out the window. Like that seems like a lot of work, but you're saying like, and did you factor in like the labor, so to speak, the amount of labor required to come to a decision? Was that like part of this as well? It's like you got the right answer, but you're 15 minutes late. Like, you know.
Yeah. I measured the time that pilots took for the decisions. This was more relevant for, so what I just told you about the trap situation with the seemingly good option. That was the third scenario that pilots had to go through, but it was not very time critical. So they could just use as much time as they wanted, basically, or not like this, but they could just spend 10 minutes on it and it wouldn't affect the situation adversely that much. But in the second scenario, it was a passenger emergency, a heart attack. So this was very time critical. And there I had an interesting finding regarding the decision times. So as you said, you would imagine that giving the recommendation makes your decision faster. But actually the recommendations were not faster than just the forward reasoning one. Because in the forward reasoning one, during normal flight, pilots could already prepare, have a good overview about their surroundings, and then, of course, they need to adjust to the new situation. Now, in normal flight, they don't know what might be happening, and then suddenly passenger emergency is happening. They need to orient themselves a bit to the new situation, but that was manageable. While for the recommendation version, the AI just comes into the situation once you have the emergency. And then you need to do this backward reasoning that we talked about initially. So you have the recommendation, and then you need to think, does it make sense or not that I get these 3 recommendations now? And this took time. So even though the best options are surfaced immediately, you need to review those. And then in the end, the time for the decision was comparable in both versions. But I had a third version where I combined basically both previous versions, where you still have the normal flight support, and then during the emergency, you would basically get the recommendation. But you would still be in this forward reasoning mode because you could prepare during normal flight. And then the recommendation comes in, and then you can just say, as a pilot, yeah, I have my idea and it fits to what the AI is suggesting me. Perfect. Then I don't need to go through a long review process of the AI recommendation. You can just say, okay, this matches my intuition. And then this actually speeds up the decision making quite significantly. So this third version was actually faster than those 2 previous versions.
Yeah, I mean that tracks to me. In the first version, then, are you saying that if there's no abnormal situation going on, there is effectively nothing on the screen? There was no interface. Like this interface is turned off during normal flight mode. It would only come on in a situation, whereas the other one was running constantly.
Yeah, exactly. That was one of the 2 major differences. So in the recommendation version, you would not have AI support during normal flight. You would need to rely on the usual tools that you have, like your map or your onboard computer, to just try to understand what's happening around you.
Okay, cool. Yeah, that tracks to me that for third version would likely, I probably would have guessed that would would perform better than the other ones. Can you talk to me so, I mean, the interesting thing here is that it suggests to me a fairly advanced design paradigm here, which is we may need to introduce what we would call friction in the user experience language. We need to potentially slow things down to speed up quality. Do you have a model or recommendation for how you think about that, or how would a team evaluate? Have I jumped the gun and jumped right to this, or have I added enough friction? Have I helped slow this down? Like, is there a way to measure if we're on track towards this forward reasoning model versus not? Like, have you given any thought, like in a commercial product, for example?
Yeah, actually, this adding friction is pretty popular. There's, for instance, a very widely cited paper that looked into cognitive forcing functions. It's what they called it, adding friction, essentially. But this was actually, I tried to circumvent this adding friction thing. I wanted to add the AI into your thinking process that is not just adding friction. So in that other study, what they found was adding friction slowed people down and it helped them make better decisions, but people essentially didn't like it because they didn't want to be slowed down.
That was my next. That's the desirability problem, right?
Yeah,
Like,
exactly.
Are they willing to pay for this when it's like feels like it's not as fast as like the competitors, like.
Yeah, exactly. So the way that I try to conceptualize this is because actually when you just give the recommendation, this what the second scenario showed, it's also adding friction because you need to review it. And I mean, it's a pretty hard task to review a recommendation that you were not involved in. So, I mean, imagine reviewing code written by other people. It's always pretty hard because you had no idea what was going on when it was written. And that was the idea behind the four reasoning, that you need to look into how people are actually working now and how you can insert AI in a way that it seamlessly fits in there and provides some benefit to you while keeping you in your usual thought process. So the way that I see it is you need to identify where the key pain points actually are in your current decision-making process and try to address those instead of just trying to solve the task entirely for users. Because that was also quite interesting in the pilots use case. Many pilots, so I had some interviews after the three scenarios, and repeatedly what the pilots told me was their main pain point or their main challenge when doing these diversion decisions, it is not actually deciding where to fly to once you have all the information. The challenge is more to collect all this information and trying to integrate it and trying to see what is actually relevant. Once you have that, it's easy to decide where to go to.
Right.
But that's something that's not really accounted for when you just give them a recommendation. Go there, go there. And that's why actually many pilots like this idea of, okay, I just have all the information, because currently that's a very big challenge for them. They have many different systems in the cockpit and need to integrate all the information from various sources, and it takes a lot of time and it's error prone. So even when you just show them the table without any AI in there, they also already like it, and it's a step up for them compared to what they currently have. But then, of course, if you just have the table, you have too much information to look at, and you need some AI to help you to focus quickly on what is important. And this is what the color highlighting then does for them. Yeah, so you need to be really mindful what AI or how your AI can actually help people in making their decision.
Maybe you could talk briefly about the ETF use case, because one thing I'm thinking about here is that Pilinst is a licensed profession. There's a lot of like playbooks and processes for how you make decisions about things. It's regulated such that I'm guessing most of the pilots were not looking at they were not looking at airport attributes and they didn't know what they meant. As opposed to like, let's take something like, which ad creative should I use from the bunch that's here? Like, which one should I double down on? Let's say I don't have like cost per acquisition if I'm trying to get leads. You don't have that information. So you have to derive it from all these other like impressions, clicks, whatever it may be. And then there's like probably some attributes in there that are like indexes or scores that, Google AdWords or whatever platform came up with. And some users may not even know what those things mean. So I'm wondering, did your system think at all about the domain knowledge of the users and like how much they really needed to know the data in order to make those decisions at all? Was the ETF thing, was that for like a skilled trader, that example, or was that for like a personal investor, like an average Joe that's trying to, build a portfolio?
Yeah, definitely the latter. So we tried to have participants who had some experience with trading ETFs, but not being professionals. And that one was built with LLMs. I mean, we didn't specifically think about the domain knowledge people might have. Here, what we focused on was more, there might be a lot of factors that you need to consider when you do your investment decision, and you might be overlooking something. So you have your intuition, and then so the study was set up that essentially the goal was to diversify your portfolio.
Okay.
We didn't want people to try to beat the market with some very clever trading, whatever, but the focus was more on diversification. And so our AIs were designed to help them see where they might be able to improve the diversification of their portfolios.
And during your screening of participants, they actually knew what diversification meant. Like they had enough knowledge to even know what that means, like bonds, stocks, cash, international, domestic. They had passed some type of requirement for that. Is that correct?
Yeah. I mean, the way that we set up the study was that there were only equity ETFs.
Yeah.
And then we also limited the factors that they needed to look into industry and geography and size of the companies. These were the main factors, I think, to keep the complexity manageable. But that was already enough to, let's say, make the decision complex enough that the study was still interesting.
Do you have any other broad findings that you want to share with the audience here, or just anything tactical that teams might be able to apply to their work if they're building recommendation prediction systems, things like this? Like how can they apply that to, say, commercial software product work?
Maybe I should briefly describe what our forward reasoning version in this instance was doing, because it was different than in the pilot version. So the basic idea was still that people should reason throughout the task. But here we used a pretty simple interaction, actually. So participants had to think about what they wanted to do and just write it down. And the AI would then take what participants wrote and insert feedback into the text. So basically expanding what they wrote with some additional factors that they might need to consider. And we also tried to design the AI in a way to avoid recommending specific ETFs. So just more like, yeah, maybe it's a good idea that you want to invest into ETF X and Y, but you might need to consider that both are heavily concentrated in the finance sector or something like this. You might need to look into different industries as well. Try to find an ETF that is in another industry, for instance. So on that level, while the recommendation version, again, it was just people click on a button and then they get a list of recommendations, very ChatGPT-like, just a list of 5 ETFs and a short explanation for each of those.
Were the users right in the first version? Were they effectively writing a prompt to get back a relevant recommendation? Is that what the prose was that they were writing up? Can you talk about that?
It was not really prompting. We had the prompting already in the back end. It was more, they should just describe what they would do now. So I want to invest into ETF X. I want to sell my shares in ETF Y because of these and those reasons.
You captured this verbally, like in a one-on-one?
Verbally, like writing down. Yeah.
Oh, okay. So you through talking to them, you asked them like, okay, your portfolio's out of balance. What do you think you need to do to rebalance it? Something like that. And then they talked you through their plan or thinking. Is it?
Yeah, textually, not verbally. Yeah, they had to write it down.
Text.
Yeah. That was a big pain point for them. Here we introduced friction. It was not really intended, but it was, of course, quite a pain and difficult for some participants to write down their plan, their rationale first. They made this suggestions how you could improve this, which is maybe something for future work. For instance, you could just have a graphical user interface where you can just input your simulated trade, so to say, and then maybe behind everything that you do, you just write a short sentence for why you would do this. This would significantly lower the effort you need to tell the AI what your plan is. But actually, it also helped participants to think through their decision-making more thoroughly. This is what you, I think, hinted towards earlier, that you need to have this friction for people to have better decisions. But actually, our plan was more, this was a side effect. Our main intention was to try to insert the AI feedback into users' own rationales. And that was the way that we chose for them to externalize it and make it explicit. Yeah, and we found that with this forward reasoning version, people had slightly more diversified portfolios. And so in that sense, it was maybe more effective. But interestingly, they found the recommendation version more insightful because it just felt maybe too unconcrete what the forward reasoning version was giving. So it was never suggesting concrete ETFs and more just hinting them, and maybe they thought, and it was also maybe, let's say, too close to what they were already thinking. while the recommendations would maybe give you some sometimes out of the box suggestions that you didn't think about. And then many participants found that more insightful, but still somehow their portfolios ended up being slightly less diversified, which was quite interesting to see. We also saw hints that with the forward reasoning version, participants had a more complete view about the situation, maybe. So they had a better understanding why they did specific things. So they had, because they performed less trades to achieve the higher diversification, while in the recommendation version, they did more trades and still had less diversification because they tended to look at each suggestion from the AI individually and didn't quite understand maybe how it fit the big picture of their portfolio.
Do you feel like there's a commercially viable recommendation you could make given that interaction design pattern you talked about, the level of friction there? Like you get to the desirability part of like building a product, or even if it's not a commercial product, just an internal decision support tool. At some point, if the friction is perceived too high or the level of effort required up front is too high, you're going to have an adoption problem. People are going to ignore it. Did you feel like you were able to extract something that could be applied forward where you wouldn't kind of lose them if you asked too much and still get the positive outcome on the back end? Or was the outcome really not that big? Like the portfolio rebalance, whatever your quality metric was there, was it not that big of a change?
Yeah. Well, the difference in diversification, it was not that big, but just combined with this finding that they needed fewer trades to achieve this slightly higher diversification, it was quite interesting. And actually, in the end, in terms of overall preference for both systems, our participants were almost 50-50 split. So some people, half of people preferred the recommendation, while the other half preferred the other version. And I think it's definitely important to reduce the unnecessary friction, let's say. So as I said, just typing out your rationale upfront with the forward reasoning version, that was admittedly maybe not the most elegant design. And there it could have helped, as I said previously, to have this graphical user interface that you have less effort inputting your rationale. And then I think this would greatly enhance the adoptability of this idea. So I think you need to reduce the friction where it is not really helping you make the decision, while you need to keep it where it helps you make the decision. So the part that's really going into your decision making, that needs to stay, while the friction that's just about using the AI, that needs to be minimized. But I think the fallacy that is around AI is often that when you solve the task entirely for users end to end, that this would somehow reduce friction. That's not always true, as seen with the pilot use case, and also in the ETF use case. Some participants told us that they need to spend quite a lot of effort to try to understand what the AI is telling them, while in the forward reasoning version, you have to spend the effort up front to write what you want to do. But once you have done that and then you get the AI feedback, it's very easy to process because it's just integrated into your own words and into your own thoughts. And then you don't need to constantly think, can I trust the AI or can't I trust it? Because it's really integrated into what you already thought. While with the recommendations, you constantly need to think, does it make sense or not? And I think that's not a problem when it's a low-stake task where it doesn't matter. But as soon as you have a task where your users care a lot about the end result, then just solving the task entirely for them, it's not really reducing the friction or the effort. Instead, it's just producing this very hard task of reviewing a foreign or like a solution that you didn't create yourself.
Yeah, part of the reason I wanted to talk to you, because it's a really interesting blend of what you could call success metrics for something like this, because you have the perceived likability of the solution. Did you like it? Would you want to use this more? And you could move that into like, do we think the market would pay for this? Then there's like the actual outcomes and quality of the decision. So maybe they don't like the version B is not liked, but from a stakes perspective, it performed the best. So maybe in an internal business context, you would kind of push towards that because they're not paying for it anyways. It's tooling. you have this likability, you have what's better. Well, it's like, which facet of better are we talking about? Perceived time on task, actual time on task, things like this. So it's it's really fascinating. The whole probabilistic space really opens up a lot of like vectors to think about, So
yeah, on that point, actually, maybe it's worth talking about the pilot use case again, because I mean, you might think that just using this forward reasoning paradigm, it's more work for users, and that might be harder to sell to users to convince them to use it. But for the pilots, I found that there it was very clear. So as I said, for ETF, it was 50-50, but for the pilots, they were like, okay, when I have this recommendation, I'm constantly in this reviewing mode, and this distracts me from my actual task. And usually, I mean, the AI should help me when it is a complicated situation, a complicated decision, when my workload is already high. And then when the AI is coming in, I can't 100% trust that it is the correct suggestion. Then I need to review it, and it just adds more workload on top of my already existing workload. So they would actually reject this idea of just giving them a recommendation, and they would prefer to stay in their workflow, and then you add AI in a more unobtrusive way. So it seems like you still have to do more for yourself, but actually AI helps you with what you are already doing instead of giving you an additional task.
Yeah, and I've read about this in the past, even with traditional machine learning forecast, like in business intelligence and metrics, and like sales propensity, like likelihood to buy or recommend which customers to call for who's most likely to buy and things like this. And you hear, if the salespeople aren't involved in the design of the product, or they can't see into the model to understand how the model's producing the recommendations, then it tends to not be trusted. And some of this tracks it rhymes with some of the stuff I've heard in the past before we even had some of these more advanced AI systems and things like that. So yeah, this is great. We probably should wrap it up here. This has been just great to dive into your research, and thanks for doing it. It's been really insightful. Is there any other kind of just high level recommendations or actionable insights you might like to share with our product and data leadership audience?
Yeah, I think when we build AI applications, we just need to resist the urge to just solve the task for users. We need to first see if it makes sense to solve the task entirely for them. There might be applications where it makes sense. For instance, when it's very easy to just check the result of the AI, then sure, it makes sense. Or if the stakes are low. But often it just doesn't make sense, and you need to spend more time into trying to understand the current working processes and see where you can insert AI in a more subtle way, maybe, or in a more unobtrusive way. Because when you just try to solve the task for users, often the idea behind it is, wouldn't it be great if we could solve this? But it would only be great if the AI would be 100% correct. But that's rarely the case. And as soon as you have even a little chance for errors, especially in high stake situations, then this whole case breaks down, so to say. It's not giving the benefit anymore that you were envisioning. And then you try to fix your design, for instance, through giving explanations or whatever, but still it's not solving the core issue that users are forced to reason backward to try to check the AI. And this just gives them a very hard additional review task. And yeah, so we need to be mindful when we design for AI. We need to design from the get-go that AI is not perfect. And this is often easier to design for when you don't try to solve the task end-to-end for users, but instead try to understand what they're doing and where AI could fit in there.
Excellent. Tony, this has been great. Where can people be in touch with you, or do LinkedIn, or where do you hang out anywhere online people could follow your work?
LinkedIn is probably best, yes.
Okay, great. I will put a link to your profile in there, and thanks for coming on Experiencing Data and sharing.
Thank you for your invitation. It was a fun conversation.
We hope you enjoyed this episode of Experiencing Data with Brian O'Neill. If you did enjoy it, please consider sharing it with the hashtag #ExperiencingData. To get future podcast updates or to subscribe to Brian's mailing list, where he shares his insights on designing valuable enterprise data products and applications, visit designingforanalytics.com/podcast.